I just want to look at finding the maximum and minimum of mod z. Now, the first one we're going to look at, if we're first of all going to sketch modulus of z minus 2 minus 2i, and that is going to equal, let that equal 1. Okay, so what I want to do is find the maximum of mod z and the minimum of mod z. Okay, so if we're looking at this here, the first thing we have to do is take the negative out, and let's sketch it. So when we take the negative out, the centre is 2, 2, and the radius is the square root of 1, which is 1. So now when we go to sketch that, we go 1, 2, 2, so it's there, 2, 2, and you go a radius of 1. That's 3, and that would go 1, and that would go 3 there and 1. So now if I'm looking at mod z just means the distance that z is from 0. Because it's like having z minus 0. That means the distance from 0. So here's 0, and what z basically does, it just moves on this circle around here. So we want to find when z is moving on that circle, when is it at its shortest distance and furthest distance. And when I draw this line, that would be the maximum of mod z. So what is that actual distance? So if you look at that, one part of it is just the radius, and the other part of it comes from, if you drew a right angle triangle here, that'd be 2, 2. That distance there would be 2 squared plus 2 squared, which is root 8. So the maximum, like the radius here is 1, the maximum would be root 8 plus 1. And if you wanted to get the minimum of mod z, then when you're doing the minimum, I'm just going to redraw the thing again. Go 1, 2, 3, 4. So when you're doing the minimum of mod z, that would mean that you would go from here, and that there, see that's your 2 and the 2, that would be root 8. Now the actual minimum that we're after is this distance here, from there to there. So what we need to do is we know that this part just in here is your radius. That part's your radius, and the radius is equal to 1. And this orange part here, this whole thing here, that would be 2 squared plus 2 squared square rooted. So you do, that's root 8. So the minimum would be root 8, but then you have to take away 1 instead of adding the 1 on. And that's basically how you do the maximum and minimum of mod z. Now, so if you had like z minus 1 plus 2i, so you go 1 and then we go 2, so that's there. And then we have a radius of 4. So it's got to go all the way down to minus 2, 4, all the way up to 5, 2, 1, 2, 3, 4. So it's right up here. And then 1, and then 2, 3, 4. So all the way down to minus 3. So it's quite a big circle here. Now, if we're looking at the maximum and minimum of mod z, so it's the distance to 0, the maximum of mod z would basically be, if you had this is the centre here, it would be the line through the centre all the way out to the furthest part on that circle there. So this part here, which is 1 and 2, that distance there would be root 1 squared plus 2 squared. So it's root 1 squared plus 2 squared, which is root 5. And this part out here is just the radius. So you'd have to add on the radius. So it's root 5 plus the radius, and the radius was 4. That would be the maximum of mod z. to get the minimum of mod z, it would be, if you go on the other side, so the minimum would be out here. That would be the minimum of mod z. So how do we get the minimum of mod z? Well, if you think about it, the whole radius goes from here to here. And we know that that green line there, this one here, is equal to root 5. So the minimum of mod z would just be root 5. Sorry, it'd be 4. Wouldn't be root 5, it would be the 4, because that's the whole radius. See the one in red? Minus, and then it would just be minus this root 5 bit, and then you would have the orange part left. Now, if you're after the maximum minimum of argz, now let's do z as this circle. So you go 1 minus 2i and have a radius of 1. Okay, so if we sketch this, then we need to take out the negative. So it's 1 plus 2i equals 1. The centre would be 1, 2. The radius would be root 1, which is 1. So you go 1, and then you go 2. And the radius is just 1. So it's just like that. Okay, so if I'm trying to find the minimum of argz, so z is anywhere on that circle, the argument, argz, just means the angle to 0. So, if that's z, argz would be the angle in there. So that's when it is a minimum. That would be the minimum of argz there, whatever that angle is. And if we want the maximum of argz, the maximum in this question, the maximum of argz is actually pi on 2, or 90, because that's the biggest value the angle could take. Because what's actually happening here is, see, as z moves on that circle, see, it takes different angles. And we're after the minimum. We've got the maximum. Let's just look at the minimum now. All right, so just going back to, it's 1 and then 2, which is there. And then we have a radius of 1, so that's 2. So if we want the smallest angle, which is here, one of the first things that you do in order to get it is, what you need to do is you get this whole big angle here, right? And then what you do is if you take away this angle here, that one in there, okay? So if we take the pink one first, the pink one looks like that, and that is a 1 and a 2, and that's alpha. So if I'm going to get that angle, tan alpha equals 2 on 1. So alpha is tan the minus 1 of 2. And in your diagram, that would be alpha right there. That's the big angle, alpha. So that is tan the minus 1 of 2. Now, the red one. If we look at the red one, okay, so we want this distance here. So we'll call that, say, x. Now, sorry, not this distance here. We don't want that distance. We actually want this angle in here. I'll call that beta. So we know the radius is 1, so that's 1. And what we need is what that value of x is there. So if we look at the actual pink diagram, so you look at this one here, we can actually get that distance because this is 1 and 2. And if we use Pythagoras, it's going to be 2 squared plus 1 squared and then square rooted it. So it's going to be root 5. Okay, so when we're looking at that, that means that if we wanted to get beta, which is the one inside the red triangle there, so that's 1, that's root 5, and this here is beta. Then if we did sine beta, we get 1 on root 5. That means that beta is sine the minus 1 on root 5. So basically, to get what the minimum of arg z is. So if we want the minimum of arg z, it's just going to be the pink one, which is tan the minus 1 of 2 minus sine the minus 1. It's just going to be sine the minus 1 of 1 on root 5. And that would be the minimum value that's z, the minimum value of arg z.